Okay, so we have 80 milliliters of a 24% solution. We're diluting it by adding 400 milliliters of normal saline. We want to find what is the percent of our new solution. We could use a dilution here to do this, or at the end of last class, we talked about our concentration adjustment formula, where we had concentration 1 times volume 1 equals concentration 2 times volume 2. So our original concentration volume, we said 24% times 80 milliliters. We're looking for the new percent, so we're looking for the new concentration. Do we know the new volume? I'll give you a hint, it's not 400 milliliters. It's 400 plus 80. Good. So we do our 24 times 80. It's 1920 equals C2 times 400 plus 80 is 480. And we're going to solve for C2 by dividing by 480. So it gives us 4. So that's telling us the concentration, the second concentration or the after concentration is 4. So 4% is what that diluted solution is. Now we could have also done this with a dilution. We started out with 80 milliliters of 24%. To do a dilution, remember, it is the amount of concentrate or serum over total volume. So we would have had the 80 milliliters over, again, it would have been 400 plus 80, which is going to reduce to 1/6. So it's a 1 in 6 dilution. So we can use that along with our percents. Of course, the 24% is the larger of the percents. So that goes on bottom with a larger number. And if you cross multiply and divide, 1 times 24 divided by 6, you will get 4%. So there are a few different ways you could approach this problem. Any questions on either of those? Any questions on the homework coming back from last week? Okay, so looking forward, we are looking at 2 weeks from today will be our test on dosage calculations and well, our other stuff that we've done this year, the concentrations, dilutions, and dosages. That test usually takes a little bit longer, so I don't try to lecture after it, so we will have the whole 2 hours to do that test, just so you guys are aware. So we've talked about concentrations. Let's focus and actually define our concentrations a little bit. So far we've just talked about concentrations as being a percent, but there are actually a few different ways to deal with this percent. One type of concentration we talk about is a weight in weight concentration. Now, weight in weight is just that. The amount, it's always going to be the amount of the solute or the serum. I'll put in solute here because often when we're doing a weight in weight, we're actually dealing with a powder that is being put into a liquid. So the amount of solute, that is the amount of the weight of that powder that is being put in. And then, of course, per 100 units of total solution. Again, that's units of weight of that total solution. So it's still the amount of the solute or the serum to total is how that is calculated. Now, as I said, this is generally when we have a powder being put into a liquid, because when you put a powder into a liquid, volume is often not conserved, but weight is always conserved. If you add 3 ounces of a powder to 8 ounces of water, you're going to get 11 ounces, period. Weight is always conserved. On the other side, when you add a powder to a liquid, volume is many times not conserved. You can add 3 milliliters of a powder to 8 milliliters of a liquid, and oftentimes not get 11 milliliters because of the whole process of dissolving. A powder dissolving into a liquid actually hides between the particles in the liquid, so it actually fits into gaps between the particles, so the volumes are not additive. If you wanted to explore this, you'd actually try it at home with salt and water. There's actually a certain amount of salt you can add to water, and the volume doesn't increase at all. But if you take like 300 milliliters of water and add 50 milliliters, is too much, about 20 milliliters of salt, it'll probably go up to about 305 milliliters. It'll only add about 5 milliliters instead of 20 milliliters. So for a weight in weight concentration, let's say we are going to add 5 grams of powder to 40 grams of sterile water. Now again, I'm going to acknowledge these units I used are grams. Remember, gram is technically a mass, but when we're dealing with our weights and masses, we just kind of blur the lines between them. We discussed that before, so I'm not going to go over it again. What would be this concentration? 5 grams is the amount of our solute, or the amount of our serum. What's going to go on bottom? Not just 40 grams, but 40 grams plus 5. It's going to be the total. So this is 5 grams over 45 grams. The grams can cancel out. 5 over 45 divides out to be 0.11111. So that would be 11.1, depending on, we're going to go to the 10th of a percent. So 11.1%, we're going to call that. So a little bit different than that one. Let's say that we have a 30% solution contains 15 milligrams of our solute. Find the amount of water that was used in that solution. So 30% means 30 out of 100, or 0.3, however you want to write it. That's going to equal the 15 milligrams is the amount of our solute. That goes on top. We're going to find X on bottom here, which is going to be our total amount. To find X down here, if I use I could have used 30 over 100, then I just cross multiply and divide. If I use 0.3, I'm going to do something similar. I'm going to put 0.3 over 1 so that I can still cross multiply and divide. Whenever my variable's on the bottom of a fraction, it's easiest if I turn it into a proportion. So I have a fraction on each side. so that I can cross multiply and divide. So 1 times 15 is 15, divided by 0.3 is 50. So X is 50 milligrams. Does that mean we add 50 milligrams of NS? No, because remember, the number that's on the bottom here is always the total solution. So that means we have 50 milligrams total minus our 15 milligrams of our medication, or our solute here, gives us 30 milligrams of NS that was added. So let's ask how much solute, how much powder, and how much water are used to make 350 milligrams of 24% weight in weight solution. So 24%. Again, I could use 0.24 or I could use 24 over 100. Either way works. I want to do 24 over 100 because now I can look at the 24 represents the amount of my solute. The 100 represents my total weight. So on the other side over here, what's going to go in there? Well, we have the 350 milligrams. Where's that going to go? That's the total. Very good. So that goes on bottom. So now I can cross multiply and divide. 24 times 350 divided by 100 is 84. So that is 84 milligrams of our solute. To get the how many milligrams of water, we could do the complement. The complement of 24% would be 76%. That's just 100 minus 24. Or, I'm going to take the easy way out here. 350 milligrams minus the 84 milligrams is 266 milligrams of water. Any questions? Okay. Well, another common concentration is called a volume in volume concentration. This one's abbreviated V/V, V and V, V over V. So here we are measuring the volume of the solute or the concentrate serum, and then the total volume again. This is most often used when we have either a liquid medication, a liquid serum that's being diluted in water, or we have an already mixed solution and we're diluting it down to a lower concentration or a lower percentage. So a dilution, in other words. So let's say that we are going to mix we're going to mix 15 milliliters of serum into 45 milliliters of NS. Now, as I said before, even when we're doing a liquid into another liquid, volume is not necessarily conserved, but we're going to have to assume that for these problems. Unless we're told the total, we're going to have to assume that we're going to add the two ingredient volumes. In many cases, I'll tell you the serum or the concentrate, and then I'll tell you the total volume. So that one we know is accurate. But if we don't, we do have to assume that we can add them. So here, we have our 15 milliliters of our serum, of our medication, and that's going to be added to 45 milliliters of water plus the 15 milliliters of the medication. So that's 15 over 60, which you divide out to be 0.25, or 25%. So to get to the 0.25, all we're doing is just taking numerator divided by denominator, 15 divided by 60. Once we're at the 0.25, we're going back to our properties of percents, moving that decimal point 2 spots to make it a percent, 25%. So let's say we have a 220 milliliter solution contains 55 milliliters of serum. Find the concentration. This one's pretty straightforward. What's going on top? 55 milliliters of serum. Yes, 55 milliliters. On bottom, are we putting the 220 or 220 plus 55? It's a 220 milliliter solution, period. The contains implies that the 55 is contained within that 220. So of course, milliliters divide out. We want to make sure that we do check to make sure those units are the same in numerator and denominator. Then 55 divided by 220 is once again 0.25. So that'll be 25%. Let's say that 800 microliters of serum are in a 20 milliliter solution. Find the concentration again. So 800 microliters of serum are in a 200 milliliter solution. So again, we know that 800 microliters is our serum. On bottom, is the 20 milliliters the whole amount, or do I have to add that to my serum? It's in a 20 milliliter solution. That is implying the whole solution is 20 milliliters. So the wording can be very subtle on these. What do we notice here, though, that we have to change before we can do anything? Milliliters and microliters. Very good. So I can either change my microliters to milliliters, or I can change my milliliters to microliters. Really doesn't make a difference. Might be, well, we'll just leave the 20 milliliters as milliliters. 800 microliters. Can you convert that into milliliters for me? Micro to milli, the key term is 1,000. We're going from 1,000th to 1,000,000th. So from micro to milli, you're either multiplying or dividing by 1,000. Which unit is bigger, micro or milli? Milli is a larger unit. If you look at it, you've got liters, deciliters, centiliters, milliliters. Then we skip 2 slots, and then it is microliters. Now, in the medical field, I probably should have abbreviated that MCL instead of MUL. Medical field tends to use MCL just because it's easier to keyboard into a computer. But anyway, a milliliter is much bigger than a microliter. So to go from micro to milli, the units are getting larger. So the number has to get smaller. So that tells us this number has to get smaller. Dividing by 1,000 is 3 decimal places. So that's actually 0.8 milliliters. So it's 0.8 divided by 20, which is 0.04, or 4%. Any questions? Okay. Our final type of concentration we're going to look at is a weight in volume, abbreviated W over V. A weight in volume concentration is also used. Now, we had mentioned the weight and weight concentration up here was often used. I'm not going to go all the way back. There's further than I thought. The weight and weight is often used when you have a powdered serum, powdered medication going into a liquid medium of some sort, liquid solvent. The weight and weight is also used when you have a powder being diluted into another carrying powder, which is not as common. Sometimes used if you're going to compress them into capsules or whatever. But weight and volume is also often used when you have a powder going into a liquid. So if we're going to have a weight in volume solution, again, the weight is the weight of the serum or the medication. I'm going to call it the solute. And the volume is still the total solution. To make this work, we need to know the relationship between weight and volume. Now again, we're talking about mass when we're dealing with metric units. But in the metric system, 1 gram is defined to be the mass of 1 cubic centimeter of water. If you recall, 1 milliliter is defined to be 1 centimeter by 1 centimeter by 1 centimeter. In other words, 1 cubic centimeter. So a cubic centimeter and a milliliter are the same thing. So if you see something that is listed as 12 cc's, that's just 12 milliliters. So 1 gram is the mass of 1 cubic centimeter or 1 milliliter of water. So a weight in volume solution is your weight in grams compared to our volume in milliliters. So let's say we have 250 milligrams of our medication. dissolved into a total volume of 50 milliliters. So we're going to put our weight to volume, 250 milligrams over 50 milliliters. And this is where it gets a little tough because our mind so wants to match up milligrams to milliliters. But what has to match up with milliliters? Grams do. So the 50 milliliters we're going to leave alone. But that 250 milligrams needs to be converted to grams. Now again, grams are larger than milligrams. So the number is going to get smaller. A milligram is 1,000th of a gram. So again, we're moving it 3 decimal places, dividing by 1,000. So 250 milligrams is 0.25 grams. .25 divided by 50 is 0.005, or a 0.5%, 0.5% concentration. So how many milligrams of our medication, of our solute, will be in 20 milliliters of a 30%, well, let's go 3%. 3% weight and volume solution. %, again, we can either do it as a 0.03 or we can do it as 3 over 100. It really doesn't matter. I'm going to do it as 3 over 100. On the other side over here, I'm going to put in the 20 milliliters. Where will that go? Top or bottom? Weight over volume. 20 milliliters is a volume. So the 20 milliliters must go on bottom. Now this is not a true ratio because we're not comparing milliliters to milliliters. So this top is not going to be milliliters. It's going to be what units is going to have to go up on top here. It'll be grams. We're always comparing grams to milliliters. So cross multiply and divide. 3 times 20 divided by 100 is 0.6 grams. Now we are asked how many milligrams. 0.6 grams is how many milligrams? 600. Grams to milligrams is 3 spots to the right, or 1,000. So move the decimal point 3 spots to the right. Any questions? Okay. Next thing I want to look at is we're going to look at Shringes. We're going to look at reading Shringes. Now the Shringes I have here are a little bit off because I've got a square end here. Most of the time your Shringes have a little bit of an angled end to them. And what that means is at the very beginning of the syringe, it's really hard to read because some of the lines, some of the divisions might be in that angled portion. So they might not even be marked. So when we look at a syringe, we try to avoid using this portion of that syringe for any sort of measurement or even counting or calculating. The first thing we need to be able to do on any syringe is to figure out what each division stands for. Of course, that depends on how it's numbered. So let's say this is numbered like this. So 1, 2, 3, and 4 milliliters like that. As I said, we generally don't use this beginning end, so we'll start at one of the numbered spots and go to the next numbered spot. So we're going from 1 milliliter to 2 milliliters. So to figure out what those divisions are, we take the difference in labeled volumes. So that'd be 2 milliliter minus 1 milliliter, which will be 1 milliliter. And then we're going to count the number of divisions between them. There's 1, 2. Now when I'm counting divisions, I'm not counting the lines, I'm counting the spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 spaces in between there. 1 milliliter divided by 10 spaces means it is 0.1 milliliter per space. So each division, each marking on that syringe is 0.1 milliliters. So if I now fill this syringe like that, I can figure out how full it is. Of course, we go from one of our labeled divisions, that's 3 milliliters. Each division is 0.1. So this was 3. This is 3.1, 3.2, 3.3, 3.4 milliliters. So on this one, what if we are labeled like this? And often, sometimes it's just numbered and they have just milliliters written up on this end or down on this end. So I'll start doing it that way here for our next couple examples. So anyway, let's go from here to here. That is from 1 milliliter to 2 milliliters. So 2 milliliters minus 1 milliliter is 1 milliliter again. How many spaces are between there? 1, 2, 3, 4, 5. There's 5 spaces. Good. So that is 1 milliliter divided by 2, which is 1 milliliter divided by 5, I should say, is 0.2 milliliters per space, per division. So now if I fill this syringe like that, I can count. This is 6 milliliters. Each space is 0.2, so I'm going to count up by 0.2. So 6, 6.2, 6.4, 6.6, 6.8 milliliters. If you prefer, and the way I would probably do it, since it's closer to the 7, I would count backwards. This is 7 milliliters, subtracting 0.2 would be 6.8. Gotta be a little more careful when you do it that way, but it does work. It's a little bit quicker in a lot of cases. So let's say this is labeled as milliliters. It's labeled like that. And we are filled to there. So our first step is let's figure out what each division is. Again, we don't like to work down here, so let's go from 1 milliliter to 2 milliliters. 2 milliliters minus 1 milliliter. That's the difference of 1 milliliter still. How many spaces do we have? So 1, 2, 3, 4, 5. And then these larger divisions tell me those are the same. So that's 5, 10, 15, 20. spaces, 1 milliliter divided by 20 is 0.05 milliliters per space. So for this one, there's a few ways I could approach it. I could start at the 1 here, and I could count up by 0.05s, which might get a little confusing. What I would do is I would count up by 5s, knowing this 1 point, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. So that's 1.70 milliliters. Another way you could have approached it is you could have counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 spaces. Did 0.05 times 14 is 0.7, and add that to the 1 that we were here at this last division. So 1 plus 0.7 is still 1.7. It is closer to the 2 than to the 1, so you could try to start at the 2 and count back by 0.05s. That one's a little bit tougher. Again, I'd probably do it by 5s, do 95, 90, 85, 80, 75, 70. A little bit more difficult. Or, I know I'm giving you like 20 different options here. Sorry about that. You could see 5, 10, 15, 20, 25. This is 25, 0.25. So count up by 25. This would be 0.50. This would be 0.75. And work between the 0.50 and the 0.75, either counting up from the 50 or down from the 75. So the trick is, the hard part is finding out what each division is. Once you know what each division is, then working in between them is relatively simple. So now a question for you. This one here is labeled 1 and 2 like this. This one has 1 and 2 here. Obviously, these syringes are not drawn to scale. The difference between them is one is going to be wider than the other, fatter than the other. One's going to be long, narrow, and skinny. The other one's going to be big around, larger diameter. Which one is going to have a larger diameter? A or B? A is going to be considerably larger in diameter. How do I know that? Well, because 1 milliliter of fluid in A fits into that amount of space. Whereas in B, 1 milliliter of fluid would have to go all the way to here. So the only way we can fit it into a shorter space is if that's a fatter syringe, a bigger round syringe. So then the next question that comes in first, I gotta go down here. If I have these syringes, and I need to administer, our order calls for 1.8 milliliters to be given to the patient. Which syringe should I use? Again, A or B. You might think, well, it really doesn't matter. On this one up here, I can find 1.8. This was 1.75. 1.8 is going to be right here. On this one, each of these is going to be 0.2, so 1.8 is right here. I can find 1.8 on either one of them. It's on a mark. I don't even have to guess in between. But I would definitely, if available, want to use syringe A. The reason why, syringe A is going to be narrower. syringe B would be wider, as we said, because it takes less volume to, or less length to get you a milliliter of volume. When we do a measurement is never perfect. If I'm focusing in on, say I'm going to focus in on where that plunger is inside the syringe. So there's the end of my plunger, the rubber seal at the end of my plunger. If my marking is right here, that's where I want that plunger to be. You ever get the plunger, the end of the plunger exactly on that marking? Yeah, most likely not, right? Chances are, if we focused in really tightly on it, that end of that plunger might be a little long like that, or just a little short like that. Not enough to make a huge difference, but if I have a narrow syringe, there's the end of my plunger. And let's say I'm off by just a little bit. Versus this one here is a wide syringe. So this is syringe A, syringe B. They don't necessarily match up with A and B from before. But let's say we're off by the exact same amount here. This is like a 1/16 of an inch. It's a little tiny fraction of an inch. Which one am I actually off by more on? A, the wide syringe. Even though the distance between the line and the end of my plunger is the same amount, this syringe is fatter. There's going to be more liquid, more fluid fitting in that space there than there is in this space, because this is a narrower syringe and this is a wider syringe. So down here, A is a better option because it's going to be a narrower syringe. We want to match the size of our syringe with the size of our dose. So here, the syringe is almost full to give them the dose. So there's going to be less error. You know, whatever little bit we're off is going to be less medication, less total volume. And you know, it's all about percents. You know, let's say that little bit of distance here is like, I don't know, 0.1 milliliters that we're off on this syringe. Of course, it depends on the syringe, right? On this syringe, well, that'd be 0.1 out of 1.8. Gives us 0.055. That's a 5% error. And actually 5.6, 5.5, 5.6% error. Well, down here, it is 4 times the diameter. Well, not necessarily 4 times. It would be twice the diameter, but 4 times the volume in that same length. So we would be off by if we're off by that same length, we'd be off by 0.4 milliliters instead of 0.1 milliliters. So now we're off by almost 20%, which is a big difference. So let's say that I fill this one up. Let's say I do have a dosage of 8.2 milliliters. So I'm filling it up to here. And I'm still off by that same distance. It's still 0.4 milliliters off. Why is that not as big of a deal? That's a bigger dosage. For 0.4 over 8.2, still less than 5%. So even though this syringe is always going to have a larger error associated with it, if you're giving a larger dose that's coming close to filling it up, the percent difference, the percent error is still reasonable. So I want to look at this syringe here for a second. What does each division, in your notes, try to figure out for me, what does each division represent on that string? This one's slightly different than any ones we've done so far because if we go between our first two marked divisions, it's 2 milliliters to 4 milliliters. So 4 minus 2 is 2 milliliters of difference. How many spaces do we have in between there? 5 spaces. So 2 milliliters divided by 5 spaces is 0.4 milliliters per space. Okay, it's about time to take our break, so let's go ahead and do that. We're at about 11:19. Let's come back about 11:29.